we rolling? Perfect. Hi, I'm Aly Barakat. Today I'm going to show you how a modern autonomous mobile robot, in short AMR, operates in real-world industrial environments. This AMR is powered by advanced sensing and power solutions from onsemi, alongside robust connectivity and safety solutions from TE Connectivity. An AMR is an intelligent robotics system capable of navigating and operating autonomously without a fixed infrastructure. Unlike traditional automation or AGVs, it does not rely on a predefined path, but instead makes real-time decisions based on its perception of the environment. This AMR is designed for dynamic environments such as factories, warehouses, and logistics centers, where it can autonomously transport materials, navigate safely around humans, and adapt to changing conditions. This flexibility enables more efficient workflows, reduces manual labor, and allows seamless integration into modern industrial operations. So let's start with sensing. The robot integrates a multi-sensor perception stack combining vision, ranging, and proximity sensing. Mono and stereo cameras based on onsemi's AR0234 image sensor provide visual input for object detection, depth estimation, and scene understanding. A 2D LiDAR delivers precise distance measurement for obstacle detection and mapping, while ultrasonic sensors ensure reliable near-field safety and collision avoidance. Each sensing modality plays a different role, which is why combining them is critical. Cameras provide rich semantic understanding of the environment, LiDAR offers accurate geometric distance measurements, and ultrasonic sensors ensure safety in close-range scenarios. By leveraging multiple sensing principles, the system becomes more robust to environmental challenges such as lighting changes, reflective surfaces, or collisions. This multimodal approach is often visualized using a spider graph, highlighting how each sensor contributes differently across criteria such as range, accuracy, robustness, and cost. All sensor data is processed on the NVIDIA Jetson Orin, acting as the central AI and robotics compute platform. Supporting the system, onsemi provides key components for power distribution, motor-driver boards, DC-DC conversion, and lighting, ensuring stable operation, efficient energy management, and safe actuation throughout the robot. From here, we move into the core intelligence of the system, the perception and control pipeline. The AMR operates in a continuous loop. It's called the sense, perceive, plan, and finally, act. During sensing, data is continuously captured from all onboard sensors. In the perception stage, the data is fused using probabilistic methods such as Kalman filtering, allowing the robot to build a consistent understanding of its position and surroundings. This leads us to localization and mapping. Using SLAM, which is short for Simultaneous Localisation and Mapping, the robot builds and updates a map of its environment in real time, while also estimating its own position within that map. This enables full autonomy even in unknown or changing environments. Next is navigation and planning. Based on the generated map, the robot computes safe and efficient paths using planning algorithms such as A* and cost map-based navigation. This allows the AMR to dynamically avoid obstacles and adapt its trajectory in real time using frameworks such as Nav2. Finally, these decisions are translated into motion. The robot uses omnidirectional mechanism wheels driven by motor controllers to execute precise movements. Continuous feedback from wheel encoders and sensors ensure accurate positioning and stable operation, closing the whole control loop. To ensure reliable system integration, TE connectivity components are used throughout the robot for rugged interconnects, sensor interfacing, and safety-critical elements such as relays and emergency stop systems. Together, this demonstrates how modern AMRs combine advanced sensing, intelligent power and actuation, and robust connectivity to operate autonomously in complex real-world environments. For more information, visit mauser.com.